All right, so now we're going to go through another example of how we solve a differential equation with an initial condition. So first, let's use separation of variables, and let's rewrite this as y cubed times x to the fourth plus 1 times dy dx. Let's add this whole thing to the right. This will be equal to x cubed times y to the fourth plus 1. And then we will multiply the right side by dx. And let's divide both sides by this y to the fourth plus 1. So let me just show the workout. So both sides by y to the fourth plus 1. And multiplying both sides by dx. So that'll get rid of this. And so then next we will have y cubed times x to the fourth plus 1 over y to the fourth plus 1 dy. And this will be equal to x cubed dx. And so then now we just divide by this group x to the fourth plus 1. And then we'll just have y cubed over y to the fourth plus 1 on the left times dy. And on the right, we'll have x cubed over x to the fourth plus 1 times dx. Well, it looks both the same. So now the variables are separated, so now we can separate integrals. It's a tall integral symbol. And for this, let's see, I was going to say use substitution. Let me think for a second. So y to the fourth, yeah. So we're going to make the u, we'll use like a u and a v, I guess. Make the u the denominator, make the u the y to the fourth plus 1, then du will be 4y cubed dy. We don't have 4y cubed, but we have y cubed. So we can have 1/4 du being equal to y cubed dy. And so that'll make it so that our left side will be 1/4 times just 1 over u, because the u is in the denominator. And we can essentially do the same thing over here, but we'll just call it something else. We'll make it we'll call it a w. W will be x to the fourth plus 1, and then dw will be 4x to the cubed dx, and then 1/4 dw will be x cubed dx. And then so on the right side, we'll have 1/4 times 1 over w dw. Okay, so let's integrate this. So this will be 1/4 times the natural log of the absolute value of u. And that'll be equal to 1/4 times the natural log of the absolute value of w plus constant C1. Now let's rewrite this in terms of y and x. So we'll have 1/4 natural log of y to the fourth plus 1 being equal to 1/4 times the natural log of x to the fourth plus 1. x to the fourth plus 1 plus c1. Okay, so this will be interesting. So you can solve for y right now, or like you can try to isolate it right now, or you could just basically use your initial condition to find c1. But in either case, you want to try to get y as put together or like as isolated as possible. So I mean, what you can do is these 1/4 will be omitted, but you're going to have a different constant. So let's say you multiply everything by 4. You would then get the natural log of y to the 4th plus 1. And then that'll be equal to the natural log of x to the 4th plus 1. We can omit the absolute value symbols because anything to the 4th will be positive. And then see the c1 will be 4 times c1, or we'll just call it c2. We'll call it a different, we'll have it be a different constant. It's not really going to be an issue. Now, what we can do is, we can combine these if you want, or use natural log, but it's really not gonna be anything that you have to like worry too much about. So in other words, it would be like e to this whole thing is equal to y to the 4th plus 1, and using the properties, and it's gonna recycle all to itself. So let me just show you. So it'll be like y to the 4th plus 1 equal to e to the natural log of x to the 4th plus 1 plus c2. So this is the same as e to the natural log of x to the 4th plus 1 times e to the c2. So it's e to the c2 is just like some coefficient, some constant. And then e to the natural log of whatever its input is would just be whatever that inside is. So this will be y to the 4th plus 1 equal to x to the 4th plus 1 times a. Let me put the a in front. And again, you can subtract 1, but you pretty much already got the y by itself. So let's go ahead. Let's use our initial condition that we're given that y of 0 is 1. So then we know it goes through the point 0, 1. So that means when x is 0, y is 1. So we're going to have 1 plus 1. 1 to the 4th is 1. Being equal to a. 0 plus 1. So then a is just equal to 2. All right, and then we'll just have y to the 4th plus 1 being equal to 2 times x to the 4th plus 1. And if you want, you can take away 1. It'll just be x to the 4th minus, or x to the 4th plus 1 at the end. But this is enough. This is fine. That's acceptable in my book for a calculus course. All right, so there you go. Hope that helps.